chromatography is the most powerful tool available in both terms of selectivity and recovery. However, the disadvantage of the all-column is that the impossibility of the column to cope with the sample that containing the particulate material. So it is not suitable for the early stage of protein isolation or purification step. Thus, many researchers and the development team has turned their interest into the biomagnetic field and particles. The use of immunofactor support, which can be made mobile or immobile, show a great promises and potential. The magnetic bead-based purification is considered as a promising alternative, as it may work with the low suspension without any clarification. The biomagnetic material has attracted fundamental and practical interest because of their potential application in broad areas. Nowadays, magnetic particles have been widely used in the biomedical fields such as immunoassay, DNA sequencing, and cell analysis. The use of the magnetic particle in protein purification presents many benefits compared to the classical procedure, as we all know, it being process simplicity and time saving. So I will talk about the magnetic beads. Okay, this magnetic beads is a smaller and also non-porous beads, and besides of their particular magnetic properties, they are also non-toxic and biocompatible. And this magnetic beads is suitable for extracting the biological molecules prior to their detection, and it is first discovered by French scientist, which is Louis Néel, and this is the person that discovered these magnetic beads. And Louis Néel is a French physicist born in Lyon, France on 22nd November 1904, and he also a winner of Nobel Physics Prize in 1970. So, for the next one is the basic principle. Okay, so basically what we should know about this topic is that it will use magnetic beads. Okay, so in one of the journals that I've read, it will coat the beads with silica. Why they use silica? Because it contains of silanol group on the surface. Okay, and they will react with coupling agents, and it will covalently attach to the ligand. Okay. And as we can see here, this one is the picture of magnetic bead, and it is coated with silica. Okay, and this one is an example of the beads with the ligand. This one is okay, and it is attached to the target protein. Okay, so for the process, okay, first one is the addition of magnetic bead. As we can see here, this one, the colorful one, is a mixture of protein. We will add magnetic beads. Okay. The next one is a specific binding. The protein will attach to the magnetic beads. For example, antigen will bind to the antibody. Okay. So the next one is supernatant removal. We will apply external magnet to attach the magnet. Okay. And supernatant will be removed. Okay. And the next one is wash and illusion. We will use illusion buffer to elute our protein of interest. Explaining about the advantage of using magnetic beads in protein separation. And first of all, this technique is very simple, few can concept. While we can see from the previous slide that has been explained by my friends, they show that it only takes 4 steps. Starting from the addition of magnetic bead until the wash and illusion process, and it takes place in a single test tube only. Next, it can be performed directly into sample containing suspended solid material. As we can see previously, it directly adds the bead into the solution. And next, due to the magnetic properties, the biomolecule can be relatively and selectively removed from the sample. So
here, we can see that this from the specific binding, the unbound protein can be easily removed as a penettant. And next, it is the feasible method for recovery of small particle, where even the smallest particle we can easily separate. Next, it is powerful and efficient for magnetic separation at large scale. And lastly, it's very gentle to the target protein, as the magnetic bead will specifically bind to our protein of interest.
After this, I will explain about other example of biomagnetic beads, which are, first one is streptavidin magnetic beads. Streptavidin is a protein that is purified from the bacteria called Streptomyces avidini. It is streptavidin magnetic beads is a bead that has a layer of paramagnetic particles inside it and are coated with the streptavidin. They are used for the capture and isolation of biotinylated molecules. Biotinylated molecules are molecules that has biotin attached to it. And the next one is protein G magnetic beads, which plays a role in immunoprecipitation. Immunoprecipitation is when we want to isolate a specific antigen from a solution. And it also able to verify antibody from the serum, and it allows high recovery and high purity of isolated antibody or antigen. And the next one is chitin magnetic beads. Chitin magnetic beads are beads that are coupled with chitin and to allow the magnetic isolation of chitin binding protein, CBD fusion protein, from cell culture pollutants, after which the matrix can be regenerated without high loss of binding capacity. I will present about the examples of magnetic separation of proteins and peptides. So as you can see here, this magnetic beads technique has been used widely for purification purpose of proteins and peptides such as proteinases, pectinases, lysozymes, polysaccharide and disaccharide, hydrolysis, albumin and hemoglobin, DNA, RNA, oligonucleotide peptide binding proteins, antibodies, and also other enzymes which includes such as alcohol dehydrogenase, catalase, cytochrome C, and many more. So I'll explain about one application of using this technique, which is recombinant protein purification from insect-derived crude extract using magnetic beads. So this application comprises of two processes. This is the first one is inoculation process. So in the very first step, the basic insect searing were conducted, in which the insects will be inoculated with baculovirus, which is the virus that have the gene that is responsible for the reproduction of recombinant protein, which is target protein. So you will go semi-automated inoculation, in which you will insert the baculovirus. Next is after 72 hours, the insect will produce larva, and then we will screen for the larva that has been infected. So the infected larva will produce the recombinant protein. So for the post-harvest process, the infected larva which has been infected with baculovirus will then undergo protein extraction by a blinder. Then it will go extract clarification by centrifugation. So the next step is to, after the centrifugation, we will get a crude extract. So this crude extract will expressing the his-tag antibody from the baculovirus that has expressed the gene. So this crude extract is then we mix with the magnetic beads, which is dynamics, and this two mixture will then undergo magnetic separation using a biomagnetic separation. So this is where the biomagnetic separation technique is used, in which it will capture the his-tag protein, which is the target protein that has been tagged with the his-tag. So after 2 hours, in this step you get the final products,
which is the recombinant protein from the
So I'm going to tell you about the application of biomagnetic separation, or in short BMS. Okay, BMS is a system that can operate with high degree of reproducibility in lesser time and effort. The application of biomagnetic expression is beneficial for the biotechnology industry with a wide range of applications in clinical and pharmaceutical settings. It attributes in easing operation and minimizing loss, as this technique is time and cost effective. When we talk about application of biomagnetic separation, people will only think about protein purification, because a lot of people avoid using chromatography since it's a bit expensive, time consuming and complicated. But apart of protein purification, actually there are other applications of biomagnetic separation, such as immuno and molecular diagnostic, nucleic acid capture, and cell sorting. For immuno and molecular diagnostic, the bit will be coated with protein G or protein A. The protein is called protein G or protein A, and it will be used to separate antibody or antigen. And then for nucleic acid capture, the magnetic bit will be coated with silica. This is to purify DNA and mRNA from mixed suspension. And for cell sorting, the magnetic bit used is the permanent magnetic bit and with label, and it is being used to separate specific cell from truth sample.
For the last part of our presentation, I'm going to talk about comparisons of technique between our method and also other more commonly used methods. And next is the overview of our comparison. And the one here in the red box is our technique, magnetic separation. And we are going to compare it with other methods such as affinity chromatography, gel filtration, and also ion exchange chromatography. And the aspects that we are comparing is their principles, their types of matrix or ligand used, and also their dilution or separation of the target protein. First, we'll look at the principles. So, for affinity chromatography, the green one here, separation of protein is based on specific interaction between the target molecule and its ligand. For gel filtration, separation is based on size and shape, and for ion exchange chromatography, it is based on the charge of the protein. So for our method, magnetic separation of our wanted protein can be done by magnetic interaction between our magnetic carrier and also our protein of interest. So for the next one, the matrix and ligand used in each of these methods. For affinity chromatography, ligand used are specific ligands that have high affinity for our protein of interest. For gel filtration, the matrix used is the bits of polysaccharides with pores that can allow separation of protein based on size and also shape. For ion exchange chromatography, the matrix used is the opposite charge group of our target protein. And for our method, the magnetic separation, we use magnetic carrier that also can attract our target protein easily. So for the next comparison, the illusion or separation of our target protein. So for affinity chromatography, the illusion of our target protein can be achieved by using specific and also non-specific binding. For gel filtration method, we use illusion buffer. And for ion exchange chromatography, we separate our protein of interest from other unwanted protein by changing the pH and also the ionic strength of the solution. And finally, for our methods, magnetic separation, we can just use a magnetic separator or simply just a magnet to separate our target protein from other unwanted materials or proteins.
And from overall explanation, I would like to conclude our presentation. So basically, biomagnetic purification is a new and effective technique that can be used and provide a lot of advantages and benefit. This is due to the result of the biomagnetic separation itself. They are more specific, have high affinity, and high productivity.
It is also time and cost effective. Apart from that,
The magnetic properties
makes the method rapid and convenient for use. So this method has great potential for rapid and highly sensitive biological separation and detection.
Disadvantage for this technology.
Thank you for the question. Actually, this magnetic beads has its own disadvantages, and the major disadvantages is that this magnetic it is not suitable for sample which in high volume of the protein because we know that the magnetic force decreases with the distance, and the further the proteins from the beads, it may result in longer time of separation and also may cause high doses of the target protein itself.
Okay, hello, hi, I'm Nasuha. I have a question for you guys. Okay, is it the bead or the external magnet that have the magnetic effect or both?
Thank you for your query. For your query, the answer is both of them have magnetic effect.